Okay, today we are going to talk about lesson 4.4, and that's over Cpctc. Basically, the main idea from this is we have to prove triangles congruent, and then any corresponding piece that isn't marked congruent can be shown congruent using Cpctc. So what does Cpctc stand for? It stands for using corresponding parts of congruent triangles to prove that missing pieces are congruent. Basically, corresponding parts of congruent triangles are congruent. That's what it stands for. We're going to spend a little bit of time talking about a checklist, not like just briefly, to help improve you writing your free-form proofs and applying the concept of Cpctc. So corresponding parts of congruent triangles are congruent. Okay, so if two triangles are congruent, so by any of the methods we know, okay, so side, 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 angle, side, angle, side, angle, 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 side, any of those, then any unmarked piece, so all pairs of corresponding angles and sides are congruent. That's what Cpctc does. So again, we have given information. We prove the triangle is congruent using one of our methods, one of our four methods. Again, we are going to add a fifth here. Again, if I'm going to critique this, we need a congruent symbol on all of these, right? So these are our four shortcuts that we know. So we have information on a picture, and then we added vertical angles or used anything from the previous unit about parallel lines. We proved them congruent. And so now we can use Cpctc to show any unmarked pieces congruent. So we have these two figures here. Hey, these are congruent by angle side angle. Okay, so we have a congruent statement written there. So once we know these are congruent by angle side angle, okay, then anything that isn't marked congruent can be marked congruent. So what can you conclude about these triangles? Well, you can conclude that, angle B is congruent to angle E. So B is congruent to, and I'll use a triple because I used a single and a double already. So we can say those are congruent, again, because B and E are right in the middle of that congruent statement. We know they're congruent. We know that segment AB, okay, so segment AB right here, I'll use a double there, and I know that DE are congruent. So we could add that. And again, that's by using Cpctc. We also know that BC is congruent to EF. Again, Cpctc. So even though the segments and angles that are not marked as congruent in the prior problem, we know that they are by using Cpctc. Corresponding parts of congruent triangles are congruent. Okay, so tell why the two triangles are congruent given the congruent statement and list all other corresponding parts that are congruent. So we're looking at my picture here. We see that those two angles at the top are congruent. We see the sides that are congruent here. What can we add to this? Well, TA is congruent to itself. Reasoning, well, again, hopefully you're shouting this out loud, maybe not out loud, but in your head, it's a reflexive property, right? So we can mark that on our picture. So now we have these triangles congruent by side, angle, side. So I know that triangle ETA is congruent to triangle MTA by side, angle, side congruence. Okay, so now I know this. Okay, so any unmarked piece can now be shown congruent, like let's say, I don't know, angle E and angle M. So they're congruent, and the reasoning for that is Cpctc, if we're writing a free-form proof. And I'm gonna be picky about that and make that a double arc mark there. We also could say that, hey, that those two angles there at A are congruent, so TAM and angle TAE, I'm going to use a triple. We can say those two angles are congruent. Again, why? Well, it's because I proved the triangle's congruent using my shortcut. So you can jump to both of these. You don't have to do them in any certain order. Okay, they're congruent by Cpctc. And then lastly, the unmarked side there, that very bottom side there, EA and MA, they're congruent by Cpctc again. Hey, one more example. I know it says you do, but I'm going to just walk through it for you. Tell why the two triangles are congruent, given the congruent statement. So when I look here, I see two sides marked. I can mark this third side congruent. Why? Because of the reflexive property. So I'll put a triple mark there. So now I can say, hey, these triangles are congruent by side, side, side congruence. Okay, one of our 4 shortcuts that we have. So because I have that now, okay, anything that's not marked, so for instance, like angle, and notice, I know that it's not fun, I don't know the right word to say, but to go ahead and have to use 3 letters to name an angle like we did here and here, but you have to. You can't just say angle J. That's not good enough, okay? So angle UJN and angle EJN are congruent, again, by Cpctc. I think you can get where this is going, okay? So those 2 angles, U and E, are congruent. We can use a triple there because we're going to use a double on the other 2 at N. So it's a good idea to think about this checklist when you're doing a free-form proof. Okay, now I know some of you are good enough that you may not need this, but others, I think you need a little bit of guidance. So what is your end goal? So that's always asking, what is it asking you to prove? So what is it telling you it wants you to prove? That's your end goal. Keep that into mind. Then you want to label your picture based on your givens. So, you know, corresponding, or sorry, not corresponding, if the lines are parallel, you know, any angles or sides that are congruent. Then you want to look at what's implied by your picture. Now, this on here is if they give you parallel lines, then you know your corresponding angles, your alternate interior, alternate exterior. This is also reflexive property, okay, implied by your picture. This is also implied by your picture, vertical angles theorem. Okay, so again, thinking about that, labeling your picture with what's on there, and then what's implied, you know, vertical angles theorem. I don't know, linear pair postulate might be value. You might have some value to it, but really we're talking about our parallel lines and all the theorems we know from that. Okay, then what can you conclude from your givens? Verify that you have 3 congruent statements. So again, if I'm going to prove triangles congruent, I have to know 3 facts. Okay, I either have to know a combination of either that matches any of our shortcuts. Okay. Again, I haven't been labeling the S's and A's a whole lot, but I've been pointing them out. I think it can get kind of cluttered if you do that. And then obviously using your postulate or theorem to prove the 2 triangles congruent. So let's think about our checklist for this free-form proof. We want to think about what we're trying to prove. We are trying to prove on here, we want to show that angle A is congruent to angle C. That's what we're trying to show. So you want to try to get there in your free-form proof. Now, put your given down on the picture, which we've done. Then you want to say, look at your picture, say, okay, is there anything I can add to this? Well, heck yeah, there is. We can add that AB, and you would want to write this down. Sorry, not AB. We know that DB is congruent to itself, and that is using the reflexive property. Okay, so we know it's congruent to itself. That's why we put the 3 marks on there. And so now I can say, oh, triangle, we'll go DAB. Oh, great, dab. Fantastic. We'll say triangle DAB is congruent to triangle. Well, again, it's got to match. So if I went DAB, it basically went single to double. So I need to go that way. So that's BCD. And when I'm saying single to double, I'm saying single tick mark to double tick mark. So and then how can we say these 2 are congruent to each other? Well, it's side 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 congruence. So we had so now that we've done this, this is where Cpctc, I know I say it really fast sometimes, is going to come into play. Can we prove angle A is congruent to angle C now? Well, yes, we can. And we can do that because we show these triangles were congruent to each other right here. And so we can use Cpctc, oh my gosh, I almost messed it up, to show that the unmarked pieces are congruent. Okay, once again, Checklist time. You want to prove that KB is congruent to AC, those segments, segment KB and AC. Again, don't mark this, don't mark what you're trying to prove on your picture. Can't do that, that's kind of cheating. All right, I know that angle KBC, so KBC is right here, is congruent to angle ACB. That's this angle here because it told me it is. I also know that that angle K and angle A are congruent there. We also know that, and those are the given, we also know that BC is congruent to itself because of the reflexive property. So I'm going to put a single mark there. And so now I know that triangle KBC is going to be congruent to, and you got to be careful with your congruence statement here. Whew, that's rough. KBC, I went double arc mark single to none. So I'm going to go double single to none. So this would be ACB. Okay, ACB. And the reasoning for that is angle, side congruence. Again, making sure your pattern matches. Okay, so hey, I proved them congruent. That means anything that's not marked could be marked if we wanted to. So you can say that KB is congruent to AC, KB and AC, because Cpctc. All right, we are trying to prove BC is congruent to AD. Now, we know that the AB and DC, those two segments are parallel. We also know that angle B and angle D are congruent. It's marked on my picture already, so I don't have to actually add it to that. Now, this is where we need to think about what we have. We do know that AC is congruent to itself, so I'm going to say AC is congruent to AC. So if we were doing a test, okay, this was a test question. If you didn't, this is kind of like the bare minimum right here. If you can't at least tell me that, I'm a disappointed teacher, okay? So you got to be able to get that down. That's the basics, okay? All right, so now this is where we're gonna stretch you a little bit. Now, hopefully you're seeing here, if this is AB, okay, and then this line right here is DC, okay, and then we have basically what we have here, and I guess I can move the point, just cheated a little bit, but what I have on my picture here is I have a transversal that comes through the middle like this on them, okay? So if I have these two sides here and here parallel with a transversal that cuts through like that, it really goes from A to C, so C could be moved kind of over here more, then I know that alternate interior are congruent. So you know that these two, I'm going to use a double here, are congruent. So you can say that angle BAC, and I think this is one of the harder things for students to see because you got to almost ignore these two pieces here and here for the moment in doing this. So angle BAC is congruent to angle ACD. Okay, and again, we just said that, hey, if I have parallel lines cut by a transversal, then I know that alternate interior are congruent. Okay, I'm going to erase some of this here just to kind of clear this up. So this is what we have here now. And if we look that we now have enough on my picture, I have two angles and a side. Now again, I've been pretty nice to you. I haven't tried to trick you up at all on these, but they do have the same pattern. It goes angle, angle, side, angle, angle, side. And more importantly, it goes single, double to the tick mark, single, double, and to the tick mark. And so it is the same pattern on here. So I can go ahead and say, you know, triangle ADC is congruent to triangle. So if I go ADC, I went no angle mark to single to double. So I'm going to go no angle mark to single to double. So it'd be CBA. So that's congruent to triangle CBA. And your reasoning for this was angle, angle, side congruence. Okay, again, it's remembering what an included side would be. So if we had marked the parallel lines congruent, which we didn't, then this would have been, you know, angle, side, angle. Okay, so we can say that BC is congruent to DA. Okay, BC and DA. BC on the right and DA on the left, and that's by Cpctc. Okay, let's try one where you're doing it. So let's draw this picture in your notes. Here's your given, and here's what we're trying to prove. Now, we talked ever so briefly about how you can show or what this means right here. So I want you to go ahead and pause the video, get your given down, try to make any connections you can, see if you can do this on your own. Try to do it on your own. So pause the video right now. Okay, and we're going to pick it up now. So, all right, MP bisects angle LMN. So we can show that with those arc marks there. We can also put the tick marks on L, the segment LM, and the segment NM, like that. Now, what else can I add to my picture? Well, I can add that PM is congruent to itself. By the way, if you would put MP, it's the same thing. By reflexive property, okay, by reflexive property there. And now we can see that, oh, we can prove these triangles congruent. Now, remember, you could have started your congruent statement a bunch of different ways. So it means that just because yours doesn't match mine doesn't mean you're wrong. I'm going to go NMP. That triangle is congruent to triangles. So if I go NMP, I went double tick mark to single tick mark. I'm going to do double to single, so I'll go LMP. And then my reasoning for this would be side angle side congruence. And then my final connection, any corresponding piece that's not marked can now be using Cpctc. So we know that we can go ahead and get what we're supposed to prove down here, that segment LP is congruent to segment NP, and that's by Cpctc. Corresponding parts of congruent triangles are congruent. You'll need to go into Canvas, open up the homework, start working on the homework, please.